Hello friends, this video Trigonometry part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Trigonometry part 1 to part 6. Let's see domain and range of sine function. This is the typical graph of sine function if you represent. So if you see what the value was 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. This is what I have asked you to learn. This was 0 degree, this is 30 degree. This is 45 degree, this is 60 degree and this is 90 degree for sine. So if you see sine 0 is 0, sine 30 is 1 by 2, so 30 will come somewhere here, it will become 1 by 2. Sine 45 1 by root 2 is bigger than 1 by 2, it will come here. Sine 60 root 3 by 2 is bigger, sine 90 is equal to 1. This is how we plot the graph. So if you plot more values of sine, you get graph like this, exactly like this. So in this function, if you see the maximum value the sine attains is 1. This is the maximum value. To get the maximum value, we can draw a line like this, horizontal line. The place where it cuts is the maximum value. So the maximum value is 1, and the minimum value if you see is minus 1. This is minus 1, and this is 1. So the maximum value is 1 and the minimum value is minus 1. So that's why the range of this function is minus 1. Also, we notice that this guy repeats after 2 pi. So this is 0 pi, this is 2 pi. So this whole thing gets repeated every time. So if you see this thing, this particular node, it gets repeated. If you copy this and if you paste this here, you get the same thing. If you copy this, you paste it here, you get the same thing. So that means after 2 pi, this gets repeated. So it rises from 0 to 1, goes down again to 0, then from 0 to minus 1, again goes back to 0, and it follows the same cycle. So it repeats after 2 pi. So two things you have learned about sine function. First thing, its domain or 0 to 2 pi, it repeats after every 2 pi, and its range is minus 1 to 1. The cos function, again we'll write the same thing, 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So this is cos, so we'll write 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Since this is cos, we'll write like this, because we knew that in cos it starts with the opposite direction. So if you see the graph, cos of 0 is 1, cos of 30 is root 3 by 2, cos 45 is equal to 1 by root 2, cos 60 is 1 by 2, and cos 90 is 0. This is the graph you'll get if you plot this. If you plot all the values, you'll get the graph like this. Also, if you plot more values of cos, you'll get graph like this. We don't know. We can find also, because we know that cos of add sugar to coffee, this we know. So this side, if you see, if you increase the value of cos, if you take any values of cos from 90 to 180, this is negative. So if you see, the value of cos from 90 to 180 is negative. If you take the value of cos from 180 to 270 is also negative, 180 to 270 is also negative, and if you take the value of cos from 270 to 360, it's positive. This is positive. Again, this comes from 0 to, so this is positive. So if you see the graph forms like this, if you plot the values, you get the graph like this. Here also, if you see, the maximum value is 1 and the minimum value is minus 1. So we can say that the domain of the function is minus 1 to 1. This is minus 1, this is 1. Also, we notice that this function repeats after 2 pi. If you see, this repeats after 2 pi. If you take this plot and the same plot, this is again the same plot. So if you break this into 2 pi form, you see the value repeats after every 2 pi. So this is the two observation we got. This repeats after 2 pi and the range of the function is minus 1 to 1. The sine also we had same thing. It repeats after 2 pi and the range is minus 1 to 1. Now I'll take tan. So again let's write 0, 1 by 2, 1 by root 2, 1 by root 2, root 3 by 2 and 1. Here again we'll write 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. This is 0 degree, this is 30 degree, this is 45 degree, this is 60 degree, this is 90 degree. Sine by cos is tan, this is sine, this is cos, this is tan. Tan becomes 0 by 1 is 0. 1 by 2 by root 3, 1 by root 3 by 2 is 1 by root 3, 1 by root 2 by 1 by root 2 is 1, root 3 by 2 by 1 by 2 is root 3, and 1 by 0 is undefined. So we have got this value of tan. Let's plot the graph. This is the graph we get. So if you see tan 0 is 0, tan of 30 is 1 by root 3, somewhere here. Tan of 45 is equal to 1. Tan of 60 is equal to root 3. Root 3 is equal to 1.732. So you'll get something here. And if you see tan of 90 is equal to infinite. The moment you touch 90, it becomes infinite. So this is the graph you get. Similarly, on the negative side, if you draw, you get this graph. So here what you observe that it repeats after pi. This is, if you see, this is pi by 2, this is pi, total length is pi, this total length is pi. So here it is repeating after every pi. In case of sine and cos, it was repeating after every 2 pi. In case of tan, it is repeating after pi. Also, the range is minus infinity to plus infinity. So that is the range. So it's the maximum is the minimum is minus infinity and the maximum is plus infinity. So in the case of sine and cos, the range was minus 1 to 1, and here it is minus infinity to plus infinity. Now let's find the domain and range of cosec function. So again, if you want to write a cosec function, we can again write our 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. So this was for 0 degree, this is for 30 degree, this is for 45 degree, this is for 60 degree, and this is for 90 degree. Now I'll say 1 by, because this was sine, say cosec. So 1 by 0 is infinity, 1 by 2 is 2, 1 by root 2 is root 2, 1 by root 2 by 3 is equal to 2 by root 3, 1 by 1 is equal to 1. So we have got this value of cosec. So if you see, cosec of 0 is infinity, south is infinity. Cosec of 30 is 1 by 2, this is 1 by 2, 30. Cosec of 45 is 1 by root 2, so this is 45 is 1 by root 2. Cos of 60 2 by root 3, and cosec of pi is 1. This is the value. And if you see all sine, tan, cos, so in the second quadrant also sine is positive. So this is also positive. This is our second quadrant values, pi by 2 to pi. Sine is positive, so cosec will also be positive, because cosec is nothing but by sine. So this guy is all positive. So you plot this graph, you get a graph like this. But if you notice, and if you plot the negative part from pi to 2 pi, you see pi to 2 pi is all negative values. So you'll get a graph like this. So if you see, this graph repeats after 2 pi. You see the graph after 2 pi. From here to here is 1. And then again, if you draw like here, it will become something like this, or something like this. So it repeats after every 2 pi. That is one observation we have got. Also, the maximum value is here is in case is infinity, and the minimum value is minus infinity. So it can have any value, cosec theta. So what we have learned, the graph repeats after 2 pi, and the maximum and the minimum value is minus infinity to plus infinity. Of cosec, again we'll draw the same thing, write the same thing, 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. This is for 0 degree, cos, this is for 30 degree, this is for 45 degree, this is for 60 degree, and this is for 90 degree, because I am talking about cos. Cos sec is 1 by cos. So I'll say sec 1 by 1 1. 1 by root 3 by 2 becomes 2 by root 3. 1 by root 2 is equal to root 2. 1 by 2 is equal to 2. 1 by 0 is equal to infinite. So we have these values of sec. So if we plot this, sec of 0 is 1, sec of 0 is 1, sec of 30 is 2 by root 3, sec of 45 is equal to root 2, root 2 is 1 by 4 here, sec of 60 is equal to 2 exactly here, and sec of 90 is equal to infinite. So you got this value. So now if you see all sine, tan, cos, so we know that this quadrant is positive. I mean this is positive, the next quadrant is negative, and next is also negative. So if you see, this is next quadrant is negative, this is next quadrant pi by 2 to pi, and next is also negative, and then comes the positive part. This is positive, and that's how the graph is plotted. So if you put all the values, we'll get a graph like this. And here also, if you note that this repeats after 2 pi. So if you take this, it will go like this. Again, it will have like this. This will be like this, like this. So if you plot this graph, this will become like this. And if you see, after every 2 pi, it repeats. You can take any 2 pi. You can take this to this is a 2 pi. So it repeats after every 2 pi. Also, the values can go from minus infinity to plus infinity. You see, the maximum value is plus infinity, and the minimum value is minus infinity. So what we have learned here now also, for cosec and sec and tan, cosec, sec, sine and cos, it repeats after 2 pi, and for tan, it repeats after pi. Now we'll take cot function. Let's write our values again. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. We'll write this in reverse order. 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. So 0 degree, 30 degree, 45 degree, this is 60 degree, this is 90 degree. Now I would write cot. Cot of this is sine, and this is cos. And cot is cos by sine. So cot becomes 0 by 1 0, 1 by 2 by 1 by root 2. This becomes 1 by root 3. This becomes 1. This becomes root 3. This becomes infinite. So I have values of cot. Let me plot this graph. So cot of 0 is infinite. So it starts with infinite. Cos of 30 is 1 root 3. So root 3 is somewhere here, 30 degree. This is 1. So pi by 4 is 1. And 60 is 1 by root 3. You'll get somewhere here. And 90 is 0. So you got this. Similarly, if you draw for negative, so when we have seen all sine, tan, cos, only sine is positive here. Tan is not positive. And a reverse of tan is cot. 1 by tan is cot. So cot is also negative. So this range, cot is negative. But if you go to third quadrant, this is third quadrant. This is third quadrant. This is second. Third quadrant, if you see, tan is positive, so cot is also positive. And the fourth quadrant, tan is negative, so cot is also negative. So we have got the graph like this. So once we have got the graph like this, we observe that this repeats after every pi. So you see, this repeats after every pi. The maximum and minimum value is minus infinity to plus infinity. Till now we have seen that sine, cos, cosec and cot, cosec and sec, that is opposite of sine cos. These guys repeat after 2 pi, and tan and cot, these repeats after pi. So please note, sine, cos, cosec and sec, these repeat after 2 pi, and tan and cot repeats after pi. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.